Hey there, Chief Specialist. It's time to move you up in the ranks. You've been doing great so far, but I want you to be a corporal. And in order to do that, you got to get through level 3 of equations boot camp. Level 3 is solving equations with fractions. We have a learning target right here. To solve equations involving fractions. Now, a couple things to be successful today. You need to know inverse operations, something that we've brought up every section so far. You gotta be able to use the inverse operations in the correct order. We'll talk about what the correct order would be depending on the situation. You need to, you know what you do to one side, you have to do to the other. So think about this balance. To keep it balanced, if you add or subtract or multiply or divide something to one side of the balance, in order to keep it level, you have to do that to the other side as well. And then finally, just a reminder to check your answer, whether it's out on the paper, whether it's just in your calculator or in your head. Checking your answer is a great tool to make sure you did it correctly. So let's get into this section. To start you off, a couple of vocab words. First of all, fraction. Not something new. It's a number that represents a part of a whole or a part of a group. Okay? So we're going to see fractions, you know, like 1 over 2. We're going to see fractions like x over 2. We're going to see fractions like x plus 4 over 2. And there's different situations where those might show up in an equation, and we need to know the correct way to solve them. Again, I'm going to put inverse operations on there again because it's so important. Inverse operations are the mathematical operations that undo each other. They're opposites. So if you have addition, you can undo it with what? Subtraction. If you have subtraction, you can undo it with what? That would be addition. If you have multiplication, which normally I'm not going to say it's an x, but for the sake of the symbol, we want to keep x as a variable. But if it's multiplication, the inverse is division. And if it's division, the inverse is multiplication. So let's get into a couple examples of what this might look like dealing with fractions in an equation. All right, here's our first example. We have -3 plus p over 2 equals 7. Now this is something that you should recognize from last section. I wanted to start you with one that you would recognize dealing with a fraction. I want you to realize also that fractions are the same as division. You can treat them both ways. So think about our two-step equations that we did last time in level 2. Our procedure to do them we talked about was start on the one side, on the side with the variable. So we know we're going to start on this left side because the variable's over there. And you first then want to use an inverse operation to undo the term that is not attached. So by the way, for this one, as long as you have the example done, that's great. You don't have to put all the steps. We already did the steps like this in section 2. So you have to use the inverse operation to undo the term that is not attached. So in this case, on the left side of our equation, the one that's not attached would be this -3. So the inverse would be to add 3. I realize that there's a plus sign after it, but in order to get rid of the -3, we have to add 3. We can't subtract because there's a plus sign. That's just going to make -6. We want to get rid of this, so we are going to add 3, sorry, to cancel that out, and we have to add 3 to the whole other side of the equal sign, which is way over here. So what's left over when we're done there is p divided by 2 equals 7 plus 3 is 10. Alright, now we can use the inverse operation to undo the term that is attached to it. And there's where the fraction comes in. P over 2 is the same thing as p divided by 2. Fractions and division are the same. Okay, they can be used interchangeably. So to get rid of that dividing by 2, we do the inverse operation here, which is multiplying by 2. So I'm going to multiply by 2, which is the same as multiplying by 2 over 1. And that cancels this out to leave just the p. And then you multiply by 2 on the right side. And you're left with 10 times 2, which is 20. So p equals 20 in this case. To check your answer, once again, if we were to check, whether it's a mental check, a calculator check, or an actual check on here, we'd be plugging in for the p. So here's where we plug it in. But we'd have -3 plus 20 over 2. And we're trying to figure out, is that equal to 7? Well, -3, 20 over 2 is 10. If you add -3 over to that, that is 7. 7 equals 7. Smiley face, we did it right. So that shows that P does actually equal 20. So let's move on to an example where it's dealing with a fraction, but it has a fraction on the whole side. This is our main new part for this section, where you have a fraction on the entire side. It says negative 8x plus 1, all divided by 3 equals negative 13. And at the end of the last video, I left you with a question to think about this, how you might go about it. Because there's a negative 8 times x, so there's some multiplying. There's a plus 1, so there's some adding. And there's dividing by 3. So there's 3 different operations. How do we get it so that there's... how do we know what to do first? Well, if you look at the top, everything on the top, this right here, negative 8x plus 1, I know we would normally get rid of the plus 1 by subtraction and then divide by negative 8. But you got to look at this as a whole group right here. A whole group that's part of a fraction. So this is on the top. This whole thing is on the top of a fraction, which is on the top of a division. So we can't touch that. We can't go to that until we get rid of that division first. So if the whole side is divided by 3, we have to get rid of that. And how do we get rid of dividing by 3? We multiply by 3. And what you do to one side, you have to do to the other. So this multiplying by 3 will cancel out the dividing by 3. And will leave us with just negative 8x plus 1, which is awesome. There's no division on there anymore. And on the right side is whatever negative 13 times 3 is, and that's negative 39. Now, if you look at this, what type of an equation is it? It's just a two-stepper. So we can go back to our steps from two-step equations. Get rid of what's not attached first. So that would be this plus 1, so we can subtract 1. Do that to the right side as well. And we're left with negative 8x equals negative 39 minus 1. Make sure you do that correctly. If you don't do it correctly, you get a completely different answer. Negative 39, and you subtract 1, you're going farther into the negatives. That's negative 40. Now, last step would be get rid of this multiplying. I know it's a negative 8, and you tend to want to somehow undo a negative 8 by adding 8, but look at what it's attached to. It's attached to the x. That means it's multiplied by the x. That means the inverse is division, and we have to divide it by that whole number. The whole number is negative 8 there. It's actually an integer, but it's the entire thing is what I'm saying. So the entire thing is divided by negative 8. That cancels itself out to be x. Divide by negative 8 on this side, and you get 5. Now, by the way, I know when we add, we do the opposite. We do subtraction. When we divide, or when we multiply by an x, we have to divide, and we don't divide by the opposite. Like we don't divide by positive 8, because that will just leave us with a negative 1 then. We have to divide it by the negative 8 here, because the negative and negative, two negatives cancel each other out. So then we're just left with x. And x equals 5 in this case. So mental check, if I were to plug in 8 or 5 for, actually I'm going to write it out. If I'm going to plug in back 5 in for x, I'd have negative 8 times 5, which is negative 40, plus 1, which is negative 39, and divided by 3, that actually is equal to negative 39. So we did it right. So to write that out in steps, which you should definitely have in your notes, when you're dealing with fractions, we did it here, we talked about it. You first have to undo the division. So get rid of that whole division. Now this is only if the entire thing is a fraction. So I'm going to note that. Once again, this is, you may want to put this on here. This is only if the entire side is a fraction. Otherwise, you're not going to do division first. It's only if the entire side is a fraction. So that's where, just want to clear that up. And once you have that done, solve it like a two-step equation. Get rid of what's attached, not attached, and then get rid of what's attached, and do your inverse operations on both sides, and you're good to go. Now, using that, I'd like you to try two examples on your own, just like the ones we just did. I'm not going to do one like the first example. This is where you have an entire fraction on one side. So follow those steps, solve each of these two examples. And why don't you pause it right now, and you can unpause it. I'll show you how to do it. All right, take a look. First one on the left here. You can see my first step, I multiplied by 4. So the entire side on the right was a fraction. So we got to get the x by itself. So to do that, I'm going to multiply by 4. So I'm working with that right side. I multiply by 4 on the left side, and I get negative 28. Now we're left with negative 28. So right here is equal to 3x plus 2. It's a two-step equation. So get rid of what's not attached first. And you can do the inverse operation. So adding 2, you do minus 2 to both sides. And now I'm left with 3x on the right side equals negative 30. And when I divide by 3, that's the last step to get the x all by itself. I am doing the inverse there of the multiplying by 3. And I end up with x equals negative 10. Now the second one is actually a step shorter. Same idea first. We have an entire fraction on one side, so I want to get rid of that division of 6 and by multiplying by 6 on both sides. So I end up with negative 6, or 5x, 5 plus x on the left side. And on the right side, I end up with 6 times negative 1, which is 6. Now, be careful with this. 5 plus x is not 5x. So 5 plus x is adding, 5x would be multiplying. So leave it as 5 plus x. And since it's a positive 5, to get that x up by itself, we're going to subtract the 5. And you can subtract 5 on both sides. And then we're done. We're left with just x on one side. So the x is all by itself. It's negative 6 minus 5 is negative 11. And we have x equals negative 11. And once again, do a mental check or a calculator check or a visual check, plugging it back in. If I do this second one, I'm going to do 5 plus negative 11, because I know my x is negative 11. Negative 11, or 5 plus negative 11 is negative 6. If I divide negative 6 by 6, I get negative 1. So it is the same on both sides. And that is a good thing. I am going to smile about that because we rocked it. Okay? Just a reminder, it's good to always check. So that's what this lesson is about. When you have an entire fraction on one side was the main thing. So what I'd like you to think about for this lesson, how are the two examples below different? How would you solve them differently? That is the question. So if you can answer that question, then you're off to a great start, and you're almost going to be a corporal here. So again, our learning target was to solve equations involving fractions, and I think we did that. So why don't you have a great rest of your day. We'll see you next time.